Hey friends, check out this exercise. We need to find the shaded area of the figure. Let's do it. First, let's find the area of this triangle using the powerful Heron's theorem. Very well, Heron's theorem tells me that the area of a triangle is equal to the square root, pay close attention, of s multiplied by s minus a, multiplied by s minus b, and multiplied by s minus c. Fantastic. And you might be wondering, what is a pass? What s is? Well, s is the semi-perimeter, which is adding the sides and dividing by 2. We add 13 plus 14 plus 15, since we're adding 10, 20, and 30. And now we add 4, 5, and 3. 4 and 5 is 9, and 3 makes 12. And with 30 that we had, that's 42. Very well. We have 42 as the perimeter of the triangle. And the semi-perimeter is half of 42, which is 21. So, with a pen, we have the square root of 21 multiplied by 21 minus. One of these sides is going to be side A. This is side A, this is B, and this is C. Very well, minus 13. Then we have 21 minus 14, and then we have 21 minus 14 again. 21 minus 15. Fantastic. All of this inside the root. You're not lost yet, are you? So we have that the area of the triangle is equal to the square root of 21. And look, 21 minus 13 is 8. 21 minus 14 is 7. And 21 minus 15 is 6. Now let's factor all of this to be able to take the square root out. Whatever we can, right? So then, let's factor it right here. Okay? We have 21. The square root, let's see. 21 can be written as 7 times 3, 7 times 3. And then 8 can be written as 4 times 2. And this 7 stays the same. And this 6 can be written as 3 times 2. And see, the area of the triangle is equal. Those that are equal, we can take them out of the root. Here we have 2 equal. We take out of the root. We have 2 equal. We take out of the root. And we have 2 equal. We take out of the root. And the square root of 4 is 2. So this here had an exact square root, which is 3 times 7 times 4. 3 times 7 is 21. 21 times 2 is 42. And 42 times 2 is 84. The area of the triangle, ladies and gentlemen, is 84. Fascinating. We have the area of the triangle over here using Heron's theorem. And now you might be saying, well, this guy is crazy. Because what we wanted to find was the area of the semicircle. But don't worry, we'll get there. Check out what we're going to do. More or less, here's the center of the semicircle. Now we draw a radius from the center of the semicircle to this tangential point between the perimeter of the semicircle and the side of the triangle. We draw this line, and this is how it looks. As we're drawing the radius to a tangential point, here we'll form 90 degrees between these two lines. If we draw another line from this point to this other tangent point, we'll also form 90 degrees. Excellent. Now let's draw a line from this vertex to the center of the semicircle. Just like that, very good. And so, what do we get? We get 2 triangles. Actually, there are more triangles, but I want you to focus on this triangle here. Look, this one here. And on this other triangle over here. The 2 triangles together make up the larger triangle, right? So, I can say that the area of the larger triangle, we'll do that over here. The area of the larger triangle is equal to the area of this triangle here, plus the area of this triangle over here. Okay? So the area of this triangle here is the base times the height divided by 2. Let's write it out. We have base times height over 2. Check who the base is. The base is 14. Very good. Who is the height? The height is this line here. It's the radius, which we'll call lowercase r. So here r. Very good. And over 2. Now let's add from the area of this triangle over here. The base is 13. The height is this line, which is also r. Very good. And all of this over 2. Excellent. I don't simplify this because we have a homogeneous sum. We have that the area of the triangle is equal. We keep the denominator and add the numerators. Numerators. We have here 14r plus 13r gives us 27r. Fantastic. We have here the area of the larger triangle of this triangle, and here too we have the area of the same triangle, so we can equate them. We can say that 27r over 2 is equal to 84. Very excellent, right? And here we move this 2 to multiply over here, and we move this 27 to divide over here. And what do we have left? Can we simplify here? Well, yes, we can, right? The 84, remember it came from 3 times 7 times 2 times 2, which is 3 times 7 times 4. So we can write it like that, 3 times 7 times 4. And there was a 2 here, right? So, what do we have left here? 1/3 of 27 is 9, and we have 9 here, and 1/3 here is 1. Very good. What do we have then? 7 times 4, which is 28. 28 times 2, which is 56. Ladies and gentlemen, the radius of the semicircle is 56/9. Fantastic. Now, having the radius, it's very easy to find the shaded area. Remember, the shaded area is the area of a semicircle. So we have pi times the radius squared over 2. What is the radius? Well, the radius is 56/9. Let's write it over here. 56/9 squared. Alright, we have the shaded area equal. 56 squared gives us 3,136. Alright, by pi and divided, look, 9 squared gives us 81, and that 81 times 2 gives us 161. Fascinating. We have here the exact shaded area. This here is square units, and by Heron's beard, the shaded area is approximately 60.8 square units. Impressive. Let me know in the comments. If you liked the video, don't forget to subscribe and hit the like button so you won't miss the next challenge. See you another time. Bye-bye. Namo sa punasan na pala sa pananani.